Alrighty, we've got some problems here to go through for test review number 2, and let's just jump right into them. On this first problem, we are given a function, a piecewise function, and a piecewise function is really kind of made up of 3 different functions. We've got one here, and one here. And we're given rules that we need to follow in order to use each of these expressions. So part A asks us to find f of 7. So what that means is they're giving us an x value. This number here represents x. They're giving us an x value of 7. In order to solve this, we need to figure out which of these rules 7 falls under. So let's take a look at this first rule here. Is 7 less than negative 5? Is 7 less than or equal to negative 5? No, it's not. 7 is definitely greater than negative 5. So that rules out this function. Let's go to the next one here. Is 7 between negative 5 and 4? Absolutely not. 7 is greater than 4. So 7 does not follow this rule. 7 is not between negative 5 and 4. So that rules out this function here. And finally, is 7 greater than or equal to 4? Yes, it is. So this is the rule that it follows, which means this is the function that we're going to use. So what does that mean? Well, that just means we take our 7 and we replace the x. And we solve the function. So we have 7 plus 2. Let me change this here, just so we know this is the function we're using. And our x value happened to be 7. 7 plus 2 is 9. So our answer for part A is 9. Let's look at B. For B, we're asked to find f of negative 10. So we just need to find which rule negative 10 falls under. Is negative 10 less than or equal to negative 5? Yes, it is. Negative 10 follows this rule, so we're going to use this particular function. So I'm going to write down that function, or that expression. We're going to replace our x with negative 10 in this case. And we'll just solve it. Negative 2 times negative 10 is 20. 20 plus 14 is 34, so the answer for part B is 34. Alrighty, part C, f of 0.3. Alrighty, what does 0.3 follow? Is 0.3 less than negative 5? No, it's not. Is 0.3 between negative 5 and 4? Absolutely. 0.3 would fall somewhere in between there. So we're going to use this function. So let me write that function down. And we're going to replace any x's in there with 0.3, but there's no x's in this particular expression. It's just the number 4. So when that happens, that's your answer. No more work to do. 4 will be our answer there. There were no x's for us to plug the value they gave us in, so we just use this value as our answer. 4 is it. And finally, part D, we are given f of negative 6.3. Negative 6.3, let's start from the bottom this time. Is negative 6.3 greater than or equal to 4? No, it's not. Is negative 6.3 between negative 5 and 4? No, it's not. Is negative 6.3 less than negative 5? Yes, it is. So that's the function we'll use for this one. And we replace the x with the value we were given of negative 6.3. Negative 2 times negative 6.3 is 12.6 plus 14, 26.6. All right, so those are not too bad. They look really complicated, but really, you take the number given, find which rule it follows, and then you just simply plug that number into that given function, or that given expression. All right, let's move on down to number 2. Assume the situation can be expressed as a linear cost function. Find the cost function. Okay, and they give us a fixed cost, and then they tell us for 40 items it costs $1,700 to produce. So that's kind of like giving us an x value and a y value. But for linear cost, we know that cost is equal to mx plus b. So let's see here. We know that this is fixed cost. This is our variable cost. And then, of course, this is the total cost. Alrighty, well, they told us the total cost was $1,700. They didn't tell us a variable cost, but they told us that 40 items, to make 40 items, so an x value of 40, costs us $1,700. And the fixed costs we know because they told us right here that the fixed cost was 100. So now we've got an equation we can solve for the unknown variable, which in this case is the variable cost. And let's see what we get here. We'll start off by subtracting 100 from both sides. That'll leave us with 1,600 equals m times 40. And now the last step is to just divide by 40 on both sides so we can get m by itself. And 1,600 divided by 40 is 40. So we've got our variable cost now, but that's not our final answer. We've got to rewrite this. They're looking for the linear cost function itself. So now that we have our variable cost, we can say c of x equals 40, that's our variable cost, x plus 100. And that's it for that one. All right, number 3, manufacturing plant. They give us a total cost to produce X items, and they want to know the average cost per item. Well, when you're trying to find average cost per item, I believe that's this here. The notation, average cost is the total cost divided by the number of items produced. All right, so that's easy enough. We can take our total cost function divide it by the number of items produced. Well, there were X items produced, so we just divide by X here. And let's see what we get here. We can, since we have a common denominator here, we can split these pieces up. So let's rewrite this as 4.7x over x plus 22,000 over x. These x's will cancel, leaving us with 4.77 plus 22,000 over x. And that'll be our average cost. And it looks like the only one that matches is this one right here, so that would be C. Okay, this next problem is a cost versus revenue problem. It says you're a manager of a firm, and we're asked to determine the break-even point to decide whether to go ahead with production of the new product. So they give us the cost function and they give us the revenue function. And the break-even point is whenever the cost is equal to the revenue, meaning you're making just enough money to cover your costs. And that's it. So we'll set those equal to find the break-even point. So we'll take our cost function, and we'll set that equal to our revenue function. And we'll solve for x here. So I'm going to get all of the x's on one side. I'm going to move the 165 over. That'll leave us with, 5115 equals, and then 220 minus 165. 55. So the last step here would be to divide by 55. And that gives us a 93. So in order to break even, we would need to make 93 units. Okay, so now, as a follow-up to this question, they may ask you, so again, we've determined that in order to break even, to make just enough money to cover our costs, we need to be able to make 93 units. So a follow-up question may be something like, if the company can produce, so the company can produce 112 units, should they go ahead with production? So should they produce this item? And the answer to this would be, well, if we need to make 93 items to break even, then if we make more, then that should be profitable, given that this is a linear function. So the more the merrier. Yes, if we can produce 112 units, that's better than 93. So we should go ahead and produce this product. Alrighty. On to number 5. We're given we're talking about a new car purchase here. It was purchased for $14,500, and then 3 years later, it was worth $9,100. And they're telling us that the depreciation, or the amount that it decreased, is represented by a linear equation. So remember, linear equations are in this form. And it's kind of like we were given an x and a y value for each of these. If we consider the year that the car was purchased the year 0, then in year 0, the car was worth $14,500. And then 3 years later, so year 3, the car was worth $9,100. Well, now we've got 2 points. We can use those 2 points to find the slope, and then we can use that information to finally finish our linear equation. So let's do that. We need to find the slope first, also known as m. And m is equal to, I just realized I wrote the second point wrong. That shouldn't be x1, y1. That should be x2, y2. And the slope formula is y2 minus y1 over x2 minus x1. Or in our case, y2 is 9,100 minus y1, which is 14,500, over x2, which is 3, minus y, or x1, sorry, which is 0. And if we work this out, I've got 9,100 minus 14,500. That's negative 5,400 over 3 minus 0 is 3. And if we do that division there, we get negative 1,800. So that tells us that the price is falling by $1,800 per year. Okay, that's not our answer. I'm just going to circle this so we know our slope. Now that we know the slope, and we've got 2 points we can use here, we can figure out the rest of our equation. We've got our slope. We still need to figure out b. So let's do that. I'm going to use this first point here. Y. Let me write this out here. So we have y equals mx plus b, right? We have a y value we can use right here. So we'll use that y value. Equals m. We have our m value. X, we have an x value. Plus b. We don't know b, but that's what we're going to find. So negative 1,800 times 0, that's just 0. That's going to go away, leaving us with 14,500 equals b. And now that we have m and we have b, we can write our linear equation. So it's y equals m, which is negative 1,800, x plus b, which was 14,500. And this would be our final equation. All right, number 6, we're given a quadratic that looks like it's in vertex form already. So if we want to find the vertex of a parabola, this is the form that's, it's good for us to have it in this form because it makes it a little easy on us. In vertex form, this point here is h, and this point here is k, and remember the vertex is given as a point, h comma k. H is always, we always want to think of H as like the opposite sign. So H in this case is -6. And K just stays the way it is, so K is 5. And that is our vertex. So that was easy to pull out of there. Now, does it open up or down? All you need to do to find that is look in the very front. Is there a negative sign here? No, there's not, which means it's going to be a happy face, or in other words, it opens upward. If there was a negative in front of that, then it would open downwards and be, a frowning face. But now we get one where we're given a parabola that's not in vertex form, and if we're going to find the vertex of something like this, then we need to use the vertex formula. And the vertex formula looks complicated, but it's not too bad. It's -b over 2a, comma, f of -b over 2a. And remember, a is the first number in front of the x squared term. B is the second number in front of the x term, and c is the number that's all by itself. So in our case, a is 3, b is -18, and c, which we don't even actually use c for this formula, but I'll write it down. C is wow, 22. Okay. Let's start plugging and chugging into the vertex formula here. The first part is -b. Well, so we have a negative, and then b is -18 over 2 times a, and a in our case is 3. So that's 18 over 6, right? 2 times 3 is 6, which is 3. So we figured out the x value of our vertex. It's 3. Now we just need to plug that 3 back into our function to figure out the y value. Alrighty, so we have our function is 3x squared, but we're plugging 3 in, minus 18 times 3 plus 22. And again, I'm just getting that's our original function here. I'm just replacing the x with the value we found here. Alrighty, so now I'm going to type that in the calculator. 3 parentheses 3 squared minus 18 parentheses 3 plus 22 is -5. And that's it. 3, -5. Alrighty, another parabola problem here. And in this problem, we're given a parabola, or at least the equation of a parabola, and we're asked to find its vertex as well as the axis of symmetry. Now, this parabola they gave us is actually already in vertex form. It may not look like it, but it is. Remember, vertex form of a parabola is vertex form y equals a times x minus h squared plus k. And remember, h and k are the x and y values of our vertex. So let's look at what we have. We're given this. Okay, so we can see there's h. Well, what is k? K is the number at the end, but we don't have anything at the end, which means k is just 0. So we have our h and we have our k. So the vertex of this parabola is hk, so in this case 4. Remember, you always use the opposite sign of h, comma k, which was just 0. So there's our vertex, and the axis of symmetry for a parabola is always the x value of your vertex. You just need to write it as an equation. So the axis is always x equals, because it's the equation of a vertical line, x equals the x value of our vertex, which in this case was 4. Alrighty, so not too bad there. Oh, and we're asked to graph it, so let me not forget about that. Can I make this smaller? Move that out of the way. So if we're going to graph this parabola, then we'll need to definitely plot the vertex, as well as maybe another point. So the vertex, let's see, 1, 2, 3, 4. The vertex is at 4, 0. So we go over 4 and up 0, which means the vertex is right there. I know that this parabola opens downward, so we know it's going to look something like this. And the reason I know that is because there's a negative sign in the front of our parabola equation. But let's see if we can make this a little more accurate. Maybe if we plug in, I always like to plug in a number close to our vertex, so make a little table here. And we already know our vertex is 4, 0, so let's pick another number, like maybe 3. Let's plug 3 into our function and see what we get. So again, we're just going to plug 3 into our equation. So that'll be negative 3 minus 4 squared, and that would be negative 1 squared, or negative 1. So when we plug in 3, we get negative 1. So for that point, we can go over 3 on the x-axis, and then down 1, and that's where our point will go. So now we can draw a little bit more accurate of a parabola. And that's it. So we would look for the graph that looks something like that. Not too bad. Let's pop back up here to number 9. Find the rule of the quadratic function whose graph has the given vertex and passes through a given point. Well, if we're given the vertex and a point, it probably makes sense to use vertex form, which I wrote on the above problem, but I'll write it again here. Okay. H and K are just come from our vertex. So H and K will each be those points there. And then the point they give us is a nice x and y value that we can plug in for x and y in our formula. And then we will just need to solve for a so that we can finish up our equation. So let's plug these numbers into our function and see if we can solve for a. So y is 67. Don't know what a is. X is 3 minus h is negative 3 squared plus k is negative 5. All right, let's see if we can simplify this a little bit. This is going to be 3 minus a negative 3. That should be 6. And it is. That'll be squared. And then we have this plus a negative 5, which is just minus 5. All right. Whoa. 67 equals a 6 squared is 36. And we have our minus 5. So we're just going to move the 5 over by adding 5 to both sides. That gets rid of it over here. What is 67 plus 5? That's 72. 72 equals a times 36. Dividing both sides by 36 should give us an a value that equals, I think 72 divided by 36 is 2. So we have our a value that we can now plug in. We've got our a, we've got our h, and we've got our k, so we can write the final form of our parabola. Y equals a, which we found to be 2. X minus h, so minus h, which is a negative 3, squared plus k, which is a negative 5. That's our final answer, but we can simplify this a little bit. For instance, minus a negative, well, that's a positive. So that becomes x plus 3. And then plus a negative 5, that's just a minus 5. And this would be the equation of our parabola. So again, given the vertex and a point, just write out vertex form, plug in the values you're given, and it shouldn't be too bad to solve for a. Alrighty, moving on to number 10. We're given the total cost formula for producing X number of textbooks. We're given the total cost formula, and then we're asked to find some things here. So, total cost is 48 times X plus 48,000. Total cost of producing X number of textbooks. Part A wants us to find the fixed costs. So if we remember from the slope formula, y equals mx plus b, the fixed cost is right here, that's b. And if we compare that to our cost function, that would be this guy right here. So our fixed costs are $48,000. Part B asks for the marginal costs. Marginal costs we can think of as the slope, or the m, in front of our variable. That would be this guy. So our marginal costs are $48 per book. Alrighty, part C, we gotta do some math. They want the total cost for producing 1,100 books. Total cost for producing 1,100 books, and then 39,000 books. But we'll take care of the 1,100 first. So I'll do my work over here. Total cost equals 48 times x, but x in this case is going to be 1100. And we can type that in our calculator. 48 parentheses 1100 plus 48,000 gives us a total cost of 100,800. Let's call that C for 1100 books was 100,800. Alrighty. Now we'll find for 39,000 books the cost to produce 39,000. 39,000 we're just plugging and chugging in here. 48 parentheses 39,000. 1,920,000. And those would be our answers for part C. And part D is asking us to find the average cost for producing 1,139,000 books. So we can actually use our answers from part C to help us with part D. Remember, average cost is just the total cost divided by the number of items produced, or divided by X. So for 1,100 books, we can take that total cost, which was, so we'll do average cost for 1,100 books is going to be 100,800, because that was the total cost, divided by the number of books, which was 1,100. Let's see what that gives us. 100,800 divided by 1,100 gives us an average cost of $91.64 if we round per book. Whoa. Okay. And the average cost for 39,000 would be the total cost for 39,000 books over 39,000 an average cost of 49.23. So those problems are a little tedious, but not too bad as long as you know the cost formula and the pieces that are represented there. For instance, this is fixed cost and this is marginal cost. It's kind of the key there.